So this is Unit 9, Free Response Question, Section B, Number 2, Part C, continued. I have a lot of it written out here before because I keep having to restart because of technical difficulties, but we will soldier on. What we've identified so far is the candidates for the absolute max are t equals 0 and t equals 8. So t equals 0 is an endpoint, t equals 8 was a critical point. We also had another critical point at t equals 4 and another endpoint at t equals 12, which we eliminated on the basis of our analysis of the derivative, the behavior of the derivative at those points. Now what we need to do is compare the values. We need to compare the values at t equals 0 and t equals 8. We have to compare the values of y. Because you could have, well, here's the possibilities of what could be going on. We could be looking at y is 18 when t equals 0, then y decreases up to t equals 4, then y increases up to t equals 8, then y decreases again, and that the increase was greater than the decrease, then that critical point at t equals 8 is going to be larger than the end point at t equals 18, and t equals 8 will be the max. However, it could be that the decrease was greater than the increase as we pass from t equals 0 to t equals 8, and then that critical point will be lower than the endpoint. So we don't know which one's higher, the endpoint or the critical point. We don't know which of these cases is going on. That's why we have to find out what y of 0 is and y of 8 is so we can compare them. So y of 0 is easy enough because they just gave it to us as an initial condition. We know that at t equals 0, the y coordinate is 18 because the roller coaster starts at the point 0, 18. So y of 0 is 18. The trick is to find y of 8. And that's one of the difficult, challenging parts of this problem. So to do it, the best way to proceed is to use this formula, which really was useful for one of our other questions as well, to look at y of 8 equals y of 0 plus the integral from 0 to 8 of y prime of t dt. That's the accumulator form of the second part of the fundamental theorem of calculus. So in order to do that, we need to know what the integral from 0 to 8 of negative t sine of pi t over 4 dt is. And that's where it gets difficult because if I try to do a u substitution with this inside function being u, then u prime is going to, or du is going to be pi over 4. But I don't have pi over 4, I have negative t. So I have this value of t that I'm not going to be able to eliminate by using a substitution. So since I have a product of two factors and one of the factors is not the derivative of the inside function, I'm going to have to integrate by parts. And so that's the challenge here, is to integrate this by parts. And it's a definite integral by parts, and it's easy to lose negative signs. So let's try to carefully do that. So the first thing I did was pull out a negative. I'm not entirely convinced that that actually made things easier, but I did it anyway. And then I'm looking at negative, the integral from 0 to 8. I'm just looking at the integral at this point. Negative the integral from 0 to 8 of t sine pi t over 4 dt. So in order to do this, I need to think about what's going to be u and what's going to be dv. So I'd like to use t as u because I'm going to do the derivative of it, and it'll just go away. So I'll have just dt. And that leaves me with sine pi of t over 4, sine of pi t over 4 as my dv. So that's going down here, sine of pi t over 4 dt as my dv. So for my u as t, I'm doing du and getting dt. For my dv equals sine pi t over 4 dt, I have to do the antiderivative. And that's also tricky because not only do I have to worry about the antiderivative of sine as negative cosine, but I also have to think that I have this inside function, and this inside function is really a linear u substitution. So that linear u substitution requires me to think about, I'm going to do the antiderivative of the outside, I'm going to keep the inside the same, and then in chain rule we would do times g prime. Since it's an antiderivative, we're going to do 1 over g prime, as we've done in the past. So the derivative of g is just pi over 4. If I do 1 over g prime, I'm going to have 4 over pi. So when I do this antiderivative going up here, this is what I get, negative cosine pi t over 4 times 4 over pi. And I can't cancel any of these things because of the cosine. So that's where I'm at there. Now I have to contend with the fact that this is where I'm doubting the wisdom of having pulled out the negative sign, because now I'm going to have a negative outside of this giant thing here where I have, here's uv minus integral v du. So I have this big barrage of negative signs that are going to have to be combined somehow. But this is my uv minus v du, And I'm just putting together the things from my table up there. You can follow through and see how I put things in the places where they are. I did take, the 4 over pi and combine it with the t and gave 4t over pi cosine pi t over 4. Everything else should be there. Now, the next thing I decided to do is let's just simplify these signs because they're a mess. So I have negative, negative, so that's going to give me positive, and I have 4t over pi cosine of pi t over 4, and that's evaluated from 0 to 8. So what's going to happen with this term is I have negative, 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 so altogether that gives me a negative. Yeah, and then I decided to pull out the 4 over pi to the front, so I have 4 over pi, integral from 0 to 8 of cosine pi t over 4 dt. All right, and then I can start to evaluate that integral. So this antiderivative over here, so I can plug in the 8, and it looks like I'm going to get 32 over pi. So 32 over pi cosine of, when I put in the 8, I'm going to get 2 pi. So cosine of 2 pi. And then mercifully, when I plug in the 0, because of this term right here, I'm going to get 0, so I don't have to worry about any of the rest of this. So I've plugged in the 8. If I plug in the 0, I'm going to get 0. We could put a minus 0 there if you want. And then I have minus 4 over pi times, and now I have to do this antiderivative. So it's good we had this one sort of as a preview. I have this inside function again, so the antiderivative of cosine is positive sine. I keep the inside function the same, pi t over 4 dt. Oh, it's not dt anymore because I'm doing an integral. And but I do have to multiply times that 1 over g prime again. So g prime is pi over 4. I have to multiply by 4 over pi. So that's my 1 over g prime right there, 1 over g prime. And that's being evaluated from 0 to 8. All right. Now let's see where else we get with this first. So now cosine of 2 pi is the same as cosine of 0, so it's 1. So this term is just 32 over pi. Here I have just minus, and I can put the 4 over pi's together and get 16 over pi squared. But when I plug in the 8, I get sine of 2 pi, which is 0. And when I plug in the 0, I also get sine of 0, which is 0. So that term goes away, and I get 32 over pi there. Now, in terms of points, the directive for points is you get 1 point for integration by parts. So it's not clear to me if that means as long as we get up to here, doing this is our integral by parts. If getting up to just here gets you the point, so I have the antiderivatives, or if I need to get all the way to the answer of it. So they said doing the integration by parts probably means getting you at least up to here. That's worth 1 point. 1 point for all that work. This is a 5-point section. All right, now, so the next thing that you're going to do is you're going to say, but wait, that's just this integral from 0 to 8 of y prime of t dt. So now I know that y of 8 is equal to y of 0 plus 32 over pi, and y of 0 we know was 18, 18 plus 32 over pi. Now, since we only had 2 candidates for the absolute max, t equals 0 and t equals 8, t equals 0, t equals 0, and t equals 8, there they are. Since y of 8, which is 18 plus 32 over pi, is greater than y of 0, which is 18, that establishes that t equals 8, and our point is 18, so y of 8, which equals 18 plus 32 over pi, is the absolute max value for y. Now, the question asked you, what is the absolute maximum value? See if I can find the question here. Let's have it handy. But I'm pretty sure the question asked you, what is the absolute value, maximum value of y, or what is the maximum value that y attains? So you have to be careful if they're asking you for y, you have to state what the y value is. Right? We have to state what that y value is. The x value might get you a point and might not. But this was the last point, is to actually have the value, the correct value, which is 18 plus 32 over pi. And the final point was for justification. And I looked carefully at what they included for justification, and it really just included the work that we did and then the observation that y of 8 is greater than y of 0, and that was their justification. So the 1 point for justification. And that is this problem.